Hello, this is Mr. Stansbury. I'm going to take you through the sample space and events notes. At the end of this, you should be able to say, I can find the sample space of an experiment and an event in the sample space. Okay, so let's talk about some terminology here. The sample space is also known as the universal set. It's the set of all possible outcomes of an experiment. Okay, and then an event is a set of outcomes in the sample space that have a particular property. So like your sample space could be flipping, like if you're flipping a coin, it would be all the heads and tails, and then an event would be just flipping heads or just flipping tails. Okay. Connections to set theory. The sample space is the same thing as the universal set. Talked about that. The outcomes are the elements of the sample space. And then events are the subsets of the sample space. Not all the subsets necessarily, but they are subsets of the sample space. Two events are complementary if exactly one of the events must occur. So if your two events are, say, rolling an even number and rolling an odd number, those are considered to be complementary events. Okay. Also, rolling a 1, 2, 3, 4, or a 5 is one event, and then rolling a 6 is another event. Those are also complementary events. Okay, let's take a look at some examples. Okay, example 3. A 12-sided die is rolled once. Let A be the event that a multiple of 2 is rolled. Draw a Venn diagram to show the sample space. So let's let this here be our event. Let A be the event that multiple of 2 is rolled. Okay, so this is going to be event A. Okay, and then that is a multiple of 2. So all the 2's on a 12-sided die would be 2, 4, 6, 8, 10, and 12. All right. Now we also have to include all the things that are not in A. So that would be 1, 3, 5, 7, 9, and 11. Right? Okay. So we have used a Venn diagram to show the sample space. Now use set notation to list the outcomes in the sample space U. Okay, so the universal set. So we're going to use our set notation for that. Okay, so our sample space, we would do U. Sorry, it should be this universal set. Writing this in set notation is going to be everything that is showing up inside this box, every possible outcome that could occur. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so that's our universal set. A is going to be everything that could happen in just, that happens, event A. Okay, so event A is 2, 4, 6, 8, 10, or 12. Okay. So that's event A. And then A prime is everything that is in the universal set that's not in A. Okay, so A prime. One way that you can do this is, let's try this, see if this helps out, is basically I take everything that I have in set A, which is 2, 4, 6, 8, 10, and 12, and I'm going to cross those off in the universal set. Okay, so 2, 4, 6, 8, 10, and 12. Okay, so then A prime is going to be everything in the universal set that's left over. So that's going to be 1, 3, 5, 7, 9, and 11, right? Just like what we had out here. Okay? Okay. Example 4. Illustrate the possible outcomes when a 4-sided die and a coin are tossed using a 2-dimensional grid. Okay, so 2D grid is literally just what it says. It's just a grid, and we're going to have on one side, we're going to have 4 possible outcomes, 1, 2, 3, and 4. And then on the other side, it's going to have to be a coin, which would be 2 possible outcomes. Okay, so I wrote the grid like this here. So here's our 4 different outcomes on the 4-sided die, and here's our 2 different outcomes on for our tossing a coin. Okay. Okay, so this outcome here could be 1 and heads, 2 and heads, 3 and heads, 4 and heads, and then this could be 1 and tails, 2 and tails, 3 and tails, 4 and tails. Okay. Another way you can do this is actually the two-dimensional grid that the book is talking about. I'm going to show you that really quick as well, but either one of those would be just fine. Okay, so here's truly what a two-dimensional grid looks like. So this point right here would be 1 in heads. This would be 1 in tails, 2 in heads, 2 in tails, 3 in heads, 3 in tails, 4 in heads, 4 in tails. Okay, so that's truly the two-dimensional grid, but a table here would work just as well. All right, now we're going to do this showing a tree diagram. Okay, so this one here, you can start with the four-sided die and then go to the coin, or you really could do the coin and then do the the four-sided die. But since it starts with the four-sided, let's start this with the four-sided die. Okay, so the first thing we've got is the die, and there are 4 different possible outcomes: 1, 2, 3, and 4. Okay, and then from the die, we can toss the coin, and there are 2 different possible outcomes for each one of those. Right, so if we roll a die, on the die we roll a 1, on the coin we can get a heads or tails. If we roll a 2 on the die, we can still get heads or tails. 3 on the die, heads, tails. 4 on the die, heads and tails. Okay, so that's the 2 different possible outcomes, one using a 2D grid and actually a table, and then another way is the tree diagram. Okay, so let's take a look at one last example here. Example 5. Use a tree diagram to illustrate the possible outcomes when a coin is flipped 3 times. Highlight the outcomes that have at least 1 tail. Okay, so we can start with the coin, and then let's do, let's see, a coin is flipped 3 times. So let's say flip 1. Okay, so we can get either heads, or we could flip that coin and we could get tails. Okay, so now if we flip heads on the first one, we have 2 possible outcomes for the second one, right? So this would be flip 2, and we could get heads again, or we could get tails, right? And then if we got tails on the first one, we flip again and we could get heads, or we could get tails. Okay, and then we've got flip 3. So if we flip heads on the first one, on flip 3, we flipped heads and then heads. On the third one, we could get heads, or we could get tails. If we did heads, tails, we can still get heads or tails on flip 3. Same thing here, we can get heads or tails, and then we can get heads or tails here as well. Does not matter what happens on previous flips as to what's going to happen on the future flips, right? So these are actually called independent events. Doesn't matter what happened before as to what's going to, it's not going to change the probability of what's going to happen on the future events. Okay, so we have our tree diagram to illustrate the possible outcomes when a coin is flipped 3 times. Highlight the outcomes that have at least 1 tail. So this one here is all heads. So let's do this. Let's do tails. We don't have to do this part here, but let's just do this to help us out here a little bit. So number of tails, heads, heads, heads. There are no tails on this tree here. So heads, heads, tails. There's 1 here. Heads, tails, heads. 1 tail there. Heads, tails, tails. There's 2 here. Tails, heads, heads is 1. Tails, heads, tails is 2. Tails, tails, heads is 2. Tails, tails, tails is 3. So highlight the outcomes that have at least 1 tail. That is going to be all of these here, right? This is the end of all these branches, right? So all these have at least 1 tail. Okay, so all these, the only one that doesn't work is heads, heads, heads. Okay? All right, that's all there is for sample space and events. If you have any further questions, please feel free to ask.